Okay, so again, some of you, especially some of my students in the other class, are incredibly stressed that they do not know how to draw these. Here's the difference in your mark if you can't draw these at the end of the year. If you can draw them, let's say you do fairly well in the class, you get a B, 76%. If you can't draw them, you get a B, 76%. Does everybody understand how little this matters? Okay. It is important because it might help some of you with the next thing we learn. And it might help some of you learning to do this without just using numbers. But if you can't do the drawings, but you know how to do it with the numbers, you're fine, okay? Something goes wrong in the teenage brain where you might know how to do 19 out of 20 things, and then you stress and worry about the 1 out of 20 things that you don't do well, so much so that you screw up the 19 things you do well. He said do. Everybody understand what I'm saying? If you can do 90, 80, 70% of the work that I give you, why are you worried about the 30 to the cost of the 70? Do you understand what I'm saying? Good. Now, that being said, you should always be striving to get 100 on everything. But I remind you all that I support local farmers because I'm pro-tractor. Pro-tractor? Protractor? Yeah. I'm not anti-tractor, nor am I Uncle Tractor. Okay, that's it. Back to math.
I was appreciating that one.
What?
That's the only joke you got today?
Yeah.
Oh, we're going to get him throughout the day.
All right. So, what math is happening right there? Oh, it's not turned on? Well, that's frustrating. What math is happening right there? Multiply. Excellent. What do those brackets do to x and negative 2? Not quite. What do brackets do? Why do we use them in math? Word. Huh? Keep things together, right? So these brackets, even though there's 2 terms in there, that's all one thing, yes? And that's all one thing, yes? So that means that is factor 1 and that is factor 2. Factors go on the outside of the drawing. X minus 2. Positive x and 2 negatives. X minus 1. There's my x, but that x is stretched, isn't it? Because it's got that x for width, but it's got that x for length.
Whoa.
Right? Right? Then it's got that bar, but it's only got this much width. What wins? Negative or positive? Negative. And then you have another one. Negative. And then you have a third one. That width. Negative. And then 2 negatives make a positive and a positive. Then all you got to do is count. Big blocks, x squared. There's one of them. Bars, there's 3 of them. 3 x's. They're all colored in, so they are negative. And 2, since they're not colored in, they're positive. Done. That's the answer. Symbolically expand. Remember, symbolically means we're just using numbers. So, if it was only a 2, the 2 would do what into those brackets? Hall Wandering 101. You guys are taking that new course we have at our school, Hall Walking 11. You guys should be getting an A in that. Yeah.
Ready?
Keep it up. Get that A. That's what matters. All walking 11. I don't care. So, where was I? Right. What is that? What math is happening there? Multiplication. So, even if you don't know how to do math, if none of this was there, what would you do? 2 times 2, which would be what? 8. And x times x, which would be what? X squared. Great. But there is something there. If that was gone, what would you do? 6, because 2 times 3, and x cubed. And it's negative. Even if you've never seen me give the class the lecture or the whole lesson on it, you all know how to multiply already. You all know that 2 times 4 is 8, and you all know that x times x is x squared. So even if I never taught you this lesson, all of you should be able to do that, right? Because we've already done our unit on exponents. What about over here? Let's pretend you don't know what you're doing. Yes, Carl? Not technically. Like, you remember, technically that 3 should be first, but I don't care. If this 3 wasn't here, would you know what to do? Yeah. And if that 2 wasn't there, would you know what to do? Yeah. So do them both. Saying you don't know how to do that when you know how to do that and that is like saying, I can only walk on odd numbered days. Because it's the same thing. If we're only going to do the first one, what's 2x times 4x? 8x squared. What's 2x times 5? 10x. What's negative 3 times 4x? Negative 12x. Since I already have an x, and I got me another x, I should probably keep them together, shouldn't I? That would be a smart thing to do. Negative 12x. And then what's negative 3 times 5? Negative 15. Then just gather it up. What is 8x squared plus nothing? 8x squared. No trick there. What is 10 minus 12? Negative 2x. What is 0? Take away 15. Negative 15. And there's the right answer. Is C any different? Of course not. If there was no 2y there, you would have what? X squared plus 2xy. And if there was no x there, what would you have? Negative 2xy. And?
Negative 4y squared.
And then you collect your like terms. 2 minus 2 is 0. And I'm done. Now, what is weird about D? There's only one set of factors. But what does that little 2 mean? That means there's 2 of whatever the base is, right? And brackets gather stuff together, right? So those brackets have gathered x minus 4 together. And then we're told it's squared, so I got to multiply it again. Can I use my shortcut there?
Yeah.
Why?
I said yeah.
I said why?
Oh, because there's 2 things.
Yeah, but the shortcut is, what are the conditions?
Not the shortcut.
You could just do it the long way, but you could use the shortcut here. because we have a single variable there, right? So no coefficient. So we know it's x squared minus 8x plus 16. If you don't remember that shortcut, that's fine. Then you do it longhand. Because shortcuts are only for saving time. X times x, x squared. X times -4, -4x. -4 times x, -4x. -4 times -4, positive 16. And you add it all up. Okay? Oh my good gravy. What's happening in E? There's nothing different though, is there? What if that y wasn't there? What would you do? He waited patiently. You would distribute. The exact same thing you've done 14 times already, right? Just because it looks different, do you do something different? Do I look different today than I did yesterday?
No.
Yes, I do. I'm wearing a rugby jersey. Uh-huh, I was. Did the rugby jersey have a big yellow elephant on the front yesterday?
I can't see the elephant part.
Oh.
Oh, there we go.
Did it?
No.
No.
I wish it would have. That's cool.
And yet, you're still sitting here learning math, yes? Do looks matter? No. Rules matter. So you do the same thing. 2y squared minus what? 8y plus what? 2. Then you go to the other one. Negative y times y. Y squared, I mean.
Y cubed.
Negative y cubed. Why did I put it out over here by itself? Because there's no other like terms. What's the next one?
4y squared.
Positive 4y squared. Why did I put it with this? Because they're both y squareds. What's the last one? Negative y. Keep the y's together. Then just gather them up. Negative y cubed. What's 2 plus 4? 6y squared. What's 8? Negative 8 minus 1.
Negative
Negative
9.
9y and 2 plus 0? 2. What's weird about the last one? It's cubed. So I need 3 of them. X minus 3 thrice. Now again, you haven't seen this, but you have seen stuff that looks like this. So apply the knowledge you already know. Just like if you were in a city you've never been to, and you push the button, and the little white dude showed up on the screen, you would walk. Because you know that's the rule. What would you do here? Something that you know. Try something and see if it makes it easier. What do you know how to do there? You know how to do that part, right? So do it. You can even use the shortcut. X squared minus 6x plus 9. What's left out front? X minus 3. Doesn't that now look exactly like that? If there was no 3 there, what would you do? Distribute. X cubed minus 6x squared plus 9x. If there was no x there, what would you do? Distribute. Negative 3x squared plus 18x minus 27. Then what would you do? Gather up. X cubed plus 0, negative 6 minus 3, negative 9x squared. 9 plus 18, 27x. 0 minus 27, negative 27. Who was right? Who was right? Well, you guys were having a big... Who was right? Oh. I'm not trying to sound angry. I'm not trying to sound even frustrated. but I am a little bit confused at the path that things are going down in this room. The problem I'm seeing is a general lack of application of knowledge that you already know, and a general lack of trying something you already know. I have seen too much blank questions on the last 2 tests. What does a blank question say about you, the student? No. Not even. What is the point of giving you a test? See what you know. So a blank question says what about you? Eric? That you don't know a thing about that question. Is that even possible to be the case in this room? It isn't. Try stuff. This looked very confusing. This you can do in your sleep. It's 1 step removed. Right? And this was not even new, was it? You know what cubed means. You know what a base is. You know what brackets do. Right? Okay. So, what you are going to do is you are going to work on page 124. And that's going to be it. I'm going to stop you in a couple of minutes. Then we're going to go over your test. Okay? Okay. My good friend Bryce, you staying for the whole block?
Sure.
Where should you be this block?
I'm a spare.
Oh. My good friend Bryce will be here to offer assistance on page 124 if you need it. Okay? Go.
Did you just want me to do the multiple choice?
Yeah, I'll mark the
Okay.
open-ended. It'll take me like 2 minutes.